Hello, everyone. Welcome to our webinar about Google Cloud Platform. I think we will wait just maybe 5 more minutes to some more people to join us. And in the meantime, I will add some quick question for anyone. If you would like to add answer and say something about yourself, that would be really helpful for us. So please introduce yourself, where are you from, city, country, and tell us if you already work with a GCP or not. Okay, we have some first answer. Welcome, Wojtek, from Krakow. And he will be use GCP in upcoming project. We also have Omar from Turkey. Hello, Omar. As he wrote, his company is using Azure Cloud. Okay, thank you.
Hello, everyone. I guess it's a high time to start. Welcome to our Q&A webinar regarding Google Cloud Platform. At the beginning, let me briefly introduce our company. So for those of you who don't know, we are the company that focuses on data and big data project. Recently also the ones that are built using cloud tools. We are more than 70 big data engineers. The company grew quite a lot for the last 7 years. You can also recognize us probably because of our community practices. So we are co-hosting community Data Tech Talks Warsaw community and co-organizing the Big Data Tech Warsaw conference. So those are the places where you could definitely hear about us. We have a lot of different data-oriented projects. We are working with open source, Kafka, Hadoop. We are working with Google Cloud pretty often, as well as other cloud providers like AWS or Azure. Here on these panels, there is me and 3 of my colleagues. So we have Gąsior, we have Piotr, Pilis, Mateusz, Pytel, and Tomasz, Żukowski. And each one of us has a couple of years with production, great experience with Google Cloud. We hold a couple of certifications, and hopefully we will manage to answer your questions. There is a couple of questions that were listed in the invitation we gathered recently, but feel free to ask additional questions during the panel. If there will be enough time, we will try to answer those as well. So just feel free. And the question number 1, what are the simplest ways to migrate my data into GCP? Regarding the migration topic, there is a separate webinar. You can find it on our YouTube channel. But mostly it comes down to properly assessing what do you want to move. Because if you are looking for an external storage, additional storage, and you won't be doing anything with this data, then the case is pretty simple. But you would like probably to move the data processes to make use of the cloud features and get some business insight. And there are, like, depending on how much time you want to spend on the migration, and what kind of benefits you would like to achieve, there are three major types of migrations. Lift and shift, which is the simplest one. You take your workload and the data and try to move it without introducing almost any changes. For some of the cases, we will talk about it in a moment, and this is possible. Then there is improve and move. For example, you want to maybe containerize your applications first, or something like that, or just replace maybe streaming service from Kafka to something more cloud native like PubSub. And there is also rip and replace approach, where you look at the business challenge you are facing, not the way you are solving it now, but try to find maybe some better tooling, maybe some different approach that will make you benefit from the cloud mostly. And briefly talking about the migration, if you are looking for something to store files, or data in file format, something to replace your HDFS, for example, in Hadoop workload, then there is Google Cloud Storage. There are a couple options for the transfer, but it's mostly limited to your network throughput. So there is a storage transfer service. There is Google Cloud GS util tool to move the data. If you have a huge amount of data, there is something like a transfer appliance where actually Google drives disk to your place, copy the data, and they then upload it on their side. But this is just about moving the data. Regarding analytical databases, so if you are using, for example, Redshift or Hive, something like that, you definitely want to check out Bigquery, which is the SQL analytics engine for Google Cloud. If it's a relational database management service, then Cloud SQL for extreme cases where you want global scalability and high workloads. You may also consider Cloud Spanner, but this is a huge price tag on this one. If you have some Hadoop workloads and you don't want to rework them, you want to just run them as they were without modifying the code, the simplest would be to look at Dataproc, which is a semi-managed Hadoop cluster on Google premises. And regarding the applications, so the easiest way currently to move the application code is, of course, to containerize it. You can use either Cloud Run, which is like a cloud function, or Knative, or fully fledged Kubernetes cluster using Google Container Engine. And last but not least, it's worth to mention that there are many partner products that can be easily hosted in the Google Cloud. So there are partner products for Redis, Confluent, Cloud Kafka, Databricks, MongoDB, Neo4j, Elasticsearch, and for many others, you can check Google Marketplace. There is probably some configuration that will make you jumpstart with your use of the cloud. I would like to emphasize the first two. Throughout our careers, those two are the most used in the data scenarios. So cloud storage and BigQuery, it's like definitely something you must check if you consider moving to the Google Cloud. Okay.
Hello, my name is Gąsior. I would like to answer the question, which GCP tools increase productivity and makes it easier to work with big data in your projects. Just wanted to share what is important, what I saw working on a couple of projects that, and actually found a nice research done by IDC, which was basically set to take 9 companies, small and medium, and compare their development lifecycle for new applications, for new features, and the number of new features released per year. So basically, what they did, they just wanted to measure what is the impact of starting using the Google Cloud platform on those companies and on those projects. So what those research showed, there is efficiency growth with developing the new applications. Yes, by 21% actually. And there is a 34% faster development life cycle for new features, which was the indicator to measure the possibility use it for new teams and for new companies. So what would you expect? It is why. So why this could happen? So this is what I can share from my experience. So those tools made me work faster than comparing with actually other clouds and on-prem tools. Basically, the excellent documentation. So it was quite easy to find the Google GCP resources, the samples for SDKs, for APIs, and for UI interface. The serverless data engineering and machine learning capabilities, mostly the Bigquery for it was very useful for fast prototyping, for not having the maintenance overhead. There are of course some pros and cons of this approach, but in general the productivity of getting the new features and new applications to production was increased. So I think it's worth considering. As well as the cloud functions, which is the possibility to run your application logic without hosting even a Docker. So you just implement it is possible in a couple of languages, but as going further, you can use the more customized approach with Docker, with Cloud Build, running those on either Cloud Run or a platform, which so that lifecycle gives you the possibility to customize further your application as long as you are adding new features, for example. The next item is automation. So basically reusing your infrastructure, reusing your metadata, and reusing your pipelines for Cloud Composer, which is the Airflow kind of implementation. The data catalog, which holds the metadata across the GCP platform, and the infrastructure, so you can have like variety of tools, Ansible, Terraform, and native to GCP deployment manager. Actually, from my experience, the first two were a bit more productive. So as I mentioned, the fast prototyping and legacy systems migrations made it more possible to basically, as Mateusz mentioned before, put more your application logic to the cloud and add new functionality, new functions going along your development life cycle. The last but not least is helpful monitoring. So audit logs, which can be accessed in Bigquery, for example. You can make dashboards and basically have very customized monitoring services with that. As well as Stackdriver, which can be customized to your needs and is much more closer, the tool which is closer to infrastructure. Yes, I think that's all from me. Thank you.
Hey, my name is Tomasz Żukowski, and I will ask a question: is storing data in Bigquery vendor lock-in? So, according to some researchers, 80% of enterprises fear vendor lock-in. What does it at all mean? If you look at Wikipedia, Vendor lock-in is something that makes a customer dependent on a vendor for products and services, unable to use another vendor without substantial switching cost. So in case of cloud solutions, we would think about changing cloud provider, for example, or going back to on-prem. This might raise some issues if you integrate too deep with a given cloud provider. How to avoid vendor lock-in and why to do so? This is always a trade-off between portability and using unique vendor functionalities. These unique vendor functionalities will make your life easier usually, or lower your daily costs. In case of Google Cloud Platform, there is a full spectrum of tools from lowest vendor locking risk to higher vendor locking risk. If we look, for example, at Compute Engine, where you're renting VMs, it should be relatively easy to change provider. Even if you use some managed services GCP offers like Google Bigtable or Dataflow, still Google tries to convince us there is low vendor locking risk because they expose some APIs which are shared with open source tools. So for Bigtable, it is HBase. For Dataflow, you can always use Apache Beam API, and risk of vendor locking will be low because you can always move your pipelines somewhere else. As Mateusz and Arek was using this example also, you can always use containers or hybrid cloud solutions, and it will also, the risk of vendor locking will be also low. But at the other end of the spectrum, we have, for example, tools like Google Bigquery, which we have our question about. What with Bigquery? It's super nice tool. It's fast. It gives us a really good possibility to explore our data. Should we store our data in a Bigquery or use it only for analytics? Today, I would like to show you how we can analyze such a situation. Let's say yesterday we were told that we have to move out of Bigquery. Are we locked in or not? So our assumption is we have 1 petabyte of data in Bigquery native storage. First info I found in documentation is Bigquery export is free. Hooray, I'm saved. Unfortunately, when I started to export data, it failed after first 50 terabytes. It comes out that there is a daily quota of 50 terabytes. It will take 20 days to export our data. We need to do it faster. Next solution we might try is export data statement, which is suggested by documentation, but it's not so cheap. Now we will have to pay for query or for slots. If we pay for query, it will be around $5,000 for extracting this data. It might sound like a significant amount of money. Let's look for something cheaper. Another option for extracting the data will be storage API, which is usually much cheaper than direct querying data, and it also allows for extracting data to GCS. In this case, it will be around $1.1 thousand, or if we have reserved slots, it will be even $800. So this sounds reasonable. So now we are happy. We exported our data to Google Cloud Storage. We are one step from moving our data to another cloud provider or back on-prem. And now we have to copy the data. And here the problems starts. If you look at network egress rates, where you have to, because if you would like to move data out of the GCP, you will need to pay. The rates are relatively high, even if we assume that we have a compression ratio of 5, so our data will be 5 times smaller. The egress will cost us 17,000 USD. So for me, To be honest, I expected when I started this exercise that the extraction cost will be significantly higher or will be the biggest part of moving the data out of GCP. It comes out that the highest cost is network egress. So to move our data out of Bigquery, it will cost around 20,000 USD. It might sound high, but if we compare it for monthly storage cost for this data, which is between 30 to 20,000 USD, depending on split of active and long-term storage, it sounds reasonable. So judging by the direct cost, I think storing data in Bigquery storage is not vendor locking. Another indirect cost, which might come out to be significant, is cost related to rewriting SQL code, because syntax for every database is slightly different, especially for UDFs. And if you have custom UDFs, porting UDFs to other languages might be needed, as Bigquery UDFs are written in JavaScript. But to be honest, all of these issues, this indirect cost, will be also there if we have data on-prem or in any other type of the database. Also, some egress costs. If we want to transfer data from physical data center to somewhere else, another physical data center, we will also need to pay for the internet. So I would say even storing data on-prem will have some cost for moving them somewhere else. So in my opinion, storing data in Bigquery is not vendor lock-in, or is not more vendor lock-in than storing it anywhere else.
Okay, thank you, Tomek. So next question is it safe to put your sensitive data to the cloud? So the question is, it depends, actually. As you can see on this simple diagram, there is two parts of responsibilities, depending on how much of management is taken care by the cloud provider, and how much of this is actually your on your plate. So in on-prem, you are responsible for everything from the hardware up to proper access policies. If it's infrastructure as a service, the hardware is managed by the provider, but you can do almost everything on this machine. If it's a platform as a service, it gets a bit easier. More of this hardware sections and semi-hardware section is covered by the provider, and the simplest case is in software as a service, because there you just need to make sure the access policies are properly configured. So yeah, briefly speaking, you can achieve probably even better security for your data using proper cloud. The condition is you will take care of security on your side. In terms of what are the security measures for the cloud providers, such providers as Google, they need to go through a lot of certifications. So you have just a couple of them listed here: ISO, FedRAMP, SOC, and PCI. And given the fact that there is many companies that use really sensitive data, so for example, we have fintech companies like Izettle, there is banking like HSBC, there are some companies that are dealing with medical data, and they happily move to the cloud. It seems like it's not an issue. It's not the case that Google will use your customers' data to tune up their search engine or something like that. This is not the case. They are must adhere to strict regulations and must ensure a lot of legal restrictions. This is also important because for some kind of data, it may be easier to pick cloud solution than to, for example, certify your own infrastructure in a way to for example, to maintain the some kind of financial or legally sensitive data. In terms of making sure that your data is secured and you do your best in securing your data, there is no better place than to go through Google Cloud Security Foundation's Blueprint Guide. It's a quite long document covering a lot of different aspects of security in different services. There is something about managing, your data, how you should manage your service account keys, how you should structure your permissions model, and so on. This is all there. This is a very broad topic, so we won't cover all that. A couple of things that we see from our experience is that definitely something that helps is infrastructure management through infrastructure as code tools, such like Terraform, where you can actually, review and easily track the changes you made to your infrastructure. Other things that can help is there is this security center in Google Cloud Platform Console, where you can there are a couple automated checks that you can apply to your infrastructure and verify if everything works well. If you are an organization, you have access to something which is called the organization node. So this is a way you can structure projects within your domain. You can also apply organization level policies and so on. And of course, audit logging, since even if something goes wrong, you would at least know what was the reason for the data leak or something like that. So there is a lot of tools, but picking a cloud provider just doesn't, it's still your responsibility to properly configure and use those services. If you do that well, you can have really top tier security policies regarding securing the sensitive data and their workloads in the Google Cloud.
The next question is how cost-effective is Bigquery in comparison to other databases? So here I would like to compare actually the five databases which are I think the most popular. So it's the Snowflake, Redshift, Bigquery, Teradata, and Azure. So cost effectiveness of those, as you can see, there are lots of factors which we can discuss. So the pricing, if you take just these factors, so usually there are the on-demand fees, which basically you pay for storage, you pay for processing, and the amount of data you read and the amount of data you store, you are billed for. So those pricings apply for Bigquery as well as for Snowflake, Redshift, for Teradata, and so for all, basically for all the all the databases listed here. The flat rate pricing is something you would like to apply when you have a certain production workloads. It is predictable, and you know you basically don't want to pay any more for the processing, rather than for you want to have the constant price basically. And in terms of comparing the Bigquery, so there is a performance comparison as well. So how much you pay for the processing, for the performance. So basically, how fast your query will run on certain databases. So the best, I think the best, the winner in this comparison may be different comparing the factor you will take into account. For example, either storage, either processing, and it really depends on the use case that will be applied. All of those databases doesn't have the the crucial differences. But what is important that, for example, like for Bigquery, you will pay $5 for for reading 1 terabyte of data, and $20 for storing 1 terabyte of data for short-term storage, and so the half of the price for long-term storage, which is more than 90 days. As your data grows, you can switch to the flat rate, which is 10K per month. It can be decreased to 8.5 if you pay just for the whole year, but it's just that kind of starting point for you. So it really lets you start small and then build as long as your application, as your usage is growing as well. Which of those has the lowest TCO really? So all those solutions except Bigquery, which is serverless and needs no maintenance from you, will need some kind of maintenance overhead. So basically, this is something you don't take into account, so you can't really compare if how many man hours you have to add to the processing, to the storage, and so on. So basically, this is something which is important to know. Yeah, so like the Snowflake is the closest, so there should be the smallest overhead for managing. So this should be price-wise the closest to Bigquery, maybe as well for multi-team and project, multi-project collaboration. So basically, this is something when you take into account the different users, the access rights, and running your application with the higher security, which basically really depends the cloud you are using. So as you know, the Redshift, Azure are more assigned to their clouds, whereas as well as Bigquery, whereas Snowflake may be more deployed on different platforms. So this is something worth taking into account when planning your spend. Basically, what is important, the cost effectiveness. So this is matching spend with income. So basically, this makes Bigquery and having the integration of audit logs, the data catalog, the billing capabilities gives you a good tool for basically finding where you can be more cost effective. So where maybe you can export your data to Google storage instead of storing this in Bigquery. However, for long-term usage, as I mentioned, it's only $10 per terabyte, which is not much more expensive than Google storage. Yeah, of course, you need to take into account the development costs for integration with other systems. So here as well, this is something which can be considered as a cloud specific. So basically, the BigQuery, Redshift, Azure will have, of course, much more tools within those clouds, whereas for example, Snowflake may be cross-platform on the one hand, but on the other hand, the tools might not be as adjusted to the platform you run it on. So, yeah. So those would be my conclusions here.
Thanks, Arek. My name is Piotr Pilis, and my question is as follows. My company is not using GCP. How can I find a Google Cloud Data Engineer job without professional experience? So probably the simplest answer here is to try to certify. So having GCP certificate is a strong and obvious signal for a recruiter. For those who have no experience with GCP, I recommend trying to approach associate engineer. It requires like 6 months of hands-on experience with GCP, but with help of Coursera, Quick Labs, and some other resources, you can do it. For cases when you have like more experience in data engineering in general, there's line of professional certificates, for example, cloud architect, data engineer, and so on. About learning resources here, I also recommend WizLabs, which has some really good practice exams. And also my tip here is to just read the documentation. In my case, when I was doing machine learning engineer certificates, I just read the AI platform docs, and it really works. So next point is about previous experience. So I think most of you have some experience with open source tools like Airflow or Spark or containers, cloud native tools, data warehouse. So in GCP, most of the work will still be connected with those tools. There are some managed version of those mentioned, like for Airflow, there's Composer, or you can host your Spark jobs on Dataproc. So for sure, your open source experience will be relevant. About some specific GCP skills required in your first such project, I will recommend to master beforehand Bigquery, especially the syntax and all of its features. GCS for storing, managing files, data flow, and identity and access management. Those are the core, I think, for the data engineer role. And what differentiate, I think, good candidates is some knowledge of Terraform or any other infrastructure as a code tools. And for some other skills required is like knowledge how to use client libraries, because it differs from the UI and what you can achieve by CLI. So my other recommendation is to get some hands-on experience by doing side projects. In my case, I did some. One of it was done on a hackathon. On a GetInData blog, there's description of what I achieved in just 2 days. So it was system for detecting anomalies connected with behavior of people on quarantine. So here I use Dataflow, Bigquery, and some other tools connected with app development. So it's really nice, and it exposes you to some troubleshooting, which will be very helpful further. And the last question probably you will ask how to find companies using GCP. So I think there are 3 main paths, or 2 maybe. For larger companies, there's a directory of companies with success story. It's on Google. It's on cloud.google.com/customers. You can filter companies by region and industry. So you can maybe find some interesting companies here. My other recommendation is to look at smaller companies like startups. This was my case. I work for some smaller company, and we have a challenge of managing a large amount of data, and we chose GCP and we stayed with it. So that's how I was getting first experience with GCP. And of course, in GetInData, we are looking for GCP engineers. We have two position open right now. So thanks.
Okay, let me just remind you, we are running out of questions. So if you want to know anything broad or specific about Google Cloud, then we are waiting for your questions. We have 2 more. So one is how effectively, from the price standpoint, put streaming data into Bigquery. Streaming insert is costly. Yeah, so that's right. Just to paint the picture here, we are talking about a scenario where we have some kind of message queue, I believe, like Kafka or PubSub as a Google managed service, and we would like to load this data to Bigquery for further analytics and processing, and the tool that does that pretty easily is the Dataflow, which can run the streaming jobs, and by default it uses something like streaming insert API, but streaming insert is paid extra. So what we can do in that case? So actually, just go back to the drawing board and ask what are the requirements, because there is no option to bypass streaming insert if we need this data in the table as soon as possible. But for scenarios where you can accept some of the latency, let's say it's 15 to 30 minutes, something like that, you could try to replace it with load jobs. So either doing this with 2 processes. So one is streaming data to Google Cloud Storage, and then something else that manages load jobs, or at least in Java SDK of Beam, you can modify the Bigquery IO sync to use the file loads function. and there is a specific configuration variable that allows you to set interval on how often those load jobs can be done. And the load job to BigQuery is at no additional costs. One thing you need to remember is that there is a quota on number of the load jobs daily. I don't remember the number, but just you need to consider it, especially if you have multiple such streaming jobs and you want to specify this upload interval to run very often. This is something that may complicate things a little. But that would be the simplest answer to that. If it's already data flow, then try to enable file loads mode, write method. If not, then try to split it to two processes. So stream to GCS and upload, with the BigQuery load job. Okay. We have one more question from what I see in the Q&A. From Omer, which GCP technologies are the data engineers in GetInData using mostly? So as we mentioned earlier, it's mostly the BigQuery and Google Cloud Storage. From someone who has like a Hadoop background or Spark background, this is really very refreshing not to be required to manage the infrastructure, to try to optimize everything, put the configuration, tune up the configuration to get some better results. This is something which is very low maintenance and low effort, and gives pretty good performance. The BigQuery, definitely cloud storage is usually used somewhere under the hood just to move the file-based data. Those two, I would add maybe Cloud Composer as something to orchestrate the workloads.
From my side, I would also focus on Dataproc and Bigquery, as they are very nice tools to use instead of on-prem Hadoop. The great thing is Dataproc starts out of the box, so you can start Dataproc without any administration knowledge. Really, anyone can start Dataproc cluster. And from side projects, as Piotr was talking about side projects, my favorite GCP tools are Cloud Run, as it gives you a chance to easily run any code you need. And from database solutions, my favorite database in GCP is Datastore.
So what I'm using mostly is the Bigquery, Dataproc a bit as well, the cloud storage, of course. It is like my favorite is really the AutoML tables, which is something actually interesting when you want to start any data science investigation. So basically you can just put the data to BigQuery tables, and then there will be automatic processes which will create the ML model based on this data, which is kind of good starting point sometimes for playing a bit with this. Yeah, so I would give this example.
We have a couple more questions. We'll just put them in the presentation in a moment, but let me read them first. So Wojciech is asking, what would you recommend for batch processing in GCP? Dataflow, Dataproc, Databricks, anything else? So if there is an option, I would go with Dataflow, definitely. Mostly because of its scaling capabilities. Mostly because of the scaling capabilities. So if you compare it, for example, to Dataproc, Dataflow can consider the amount of data that is to process in the backlog or the lag on the input stream in terms of streaming. So it scales really quickly. It can scale up to hundreds of machines if it discovers that the load is huge. If you look at the resources, like in terms of data proc storage, it will take a couple of iterations for it to go out of resources and then scale up again. And as for the data flow, you don't manage, at least for batch jobs, you don't manage infrastructure under the hood. So this is a service which takes care of its own infrastructure. You just run the job and the rest is taken care by the service. So definitely Dataflow, Dataproc, I would consider either if we already have the workloads that are based, on Spark, and we don't want to spend a lot of time. And the other reason may be that we have the team that has, good skills using Spark and so on, and it takes time to switch framework, so it may be a good idea to stick with Dataproc. And we have the same question for streaming. As for streaming, I would go with the Dataflow as well. You can run some streaming services in Dataproc, but yeah, I would say the recommended is Dataflow, unless you have specific reasons not to go that route. Another question is, what are the key technologies that GCP currently misses in your projects? So you need to take advantage of open source tools. So let me answer from my side. In terms of data engineering, it's pretty good coverage of features. I would say what we definitely miss right now is some tool sets regarding machine learning. It changes rapidly in Google Cloud, but due to some specific customer requirements or some specific cases, we support our solution by onboarding open source tools related to machine learning. So things like MLflow, things like Kedro project framework. This is a stuff that works well with. It's easily embeddable with use of container hosting, like on Kubernetes and so on, and plays well with other aspects of the cloud projects in GCP. So, for example, in our case, data lake, which is BigQuery based.
So let me add some details from my side. In the project I'm currently working on, we are definitely missing a tool for tracking and presenting data lineage. We would like to know from where our data originates, how was it processed. But for now, it's not able. We are not able to present it with GCP tools. But fortunately, it's also possible to solve this with open source tools. What is important for us, native GCP tools, like for example Bigquery, helps in such work. For example, in Bigquery, if you look at audit logs, you can get such info for free, and it is enough to load it to the tool you are using.
Let me just refresh. Yeah, so another question that popped up. When it comes to infrastructure management, is Ansible sufficient enough, or Terraform is also required? So I am not Ansible specialist. I would say if you have to choose, go with Terraform because it has pretty good GCP support. So you can manage almost everything that you can do through API, you can do through Terraform. So you can actually script up even your whole organization, including projects, all the services, service accounts. And this is also something that we often, even with enterprise level customers, they build their standards of infrastructure management with Terraform rather than Ansible. So I would say, guys, maybe you know a bit more on Ansible. I'm not sure how it covers the infrastructure management.
I think like we are using in some projects as well as Ansible as Terraform. There are some edge cases, of course, where the one or another is one or another will lack some functionality you would like. Yeah, but like I think it is something that it is really very based on your use case. So what I would recommend is to take the exact functionality you would like to manage and research in the scope of this functionality rather than kind of general. So from my standpoint of view.
Okay, so let's maybe wait just a minute more if any question arises. Okay. Seems like there is no more questions. So thank you very much for the attendance. We hope it was interesting for you. Let me invite you, if you would like to find out more on what we are doing, we are eager to share either on our YouTube channel, where you will find a bunch of pre-recorded webinars, or in our blog at GetInData.com.